Hi everyone! In this video, we will learn about error in metrology. Do you know what is error in metrology? Let's have learn with us. Error in the metrology defined as difference between true value and measure value. For your information, true value is the average of the infinite number of measurements, and measure value is precise value. Also, in this topic, we will learn two types of error, which is systematic error and random error. In addition, these errors are commonly occur in the experiments. Systematic error. Systematic error, also known as can be avoided error, which is defined as consistent, repeatable error associated with faulty equipment or flawed experiment design. If properly analyzed, this error can be eliminated, which also called controllable errors. There are a few types of systematic error, which is environment error, elastic deformation errors, and alignment errors. For environment errors, it is due to ambient condition, which is the condition external measuring device, including condition in the area surrounding the instrument have changed. As example, the change in temperature or magnetic field of surrounding can affect the result data. For elastic deformation errors, it is occur when force exerted on a material. This event can cause the elongation of a material and change in shape. Sometimes, this error can cause necking on the object, and then fracture of material are occur. Alignment errors. This error occur when the checking of an instrument is not correct, aligned with the direction of the desired measurement. Basically, this error will be developed generally while measurement of a given job is carried out using dial gauge or steel rule. Random error. Random error is caused by unknown and unpredictable change in the experiment. This error cannot be eliminated. The type of random error is parallax error and gross error. For parallax error, it is displacement in the apparent position of an object viewed along two different lines of sight. If the eye is not directly across from what is being measured, the measuring scale will give an inaccurate reading. For gross error, this class of error mainly covers by human mistake in reading or using instruments and in calculating measurement and recording data result. One common gross error frequently committed by beginners in measurement work involves the improper use of instrument. As example of error gross, a person is reading pressure gauge 1.01 Newton over meter square as 1.10 Newton over meter square.
Assalamualaikum. My name is Muhammad Daniel Hakimi. I'll be talking about errors in metrology, especially the labeling of equipment, advantage and disadvantage. First of all, the overview. Labeling equipment is a broad term that describes machinery used to label and identify products. Labeling equipment embodies the singular need for product identification. It is essential and encompasses many different pieces of machinery brought together to achieve the desired results. Next, there are three processes. The first one is calibrate, labeling, and applicator. Okay, for calibrated. All calibrated test equipment is assigned a calibration cycle, usually 12 months. The equipment is verified to operate within the specific tolerance of its metrology procedure each cycle. However, there are non-calibrated equipment identified as no calibration required, also known as NCR. It requires no regular verification or maintenance. The primary purpose for identifying equipment as NCR is to alleviate concerns that the user would have pertaining to its calibration status. There are also out-of-service equipment that is no longer needed, serviceable, or cannot be calibrated will be physically segregated and identified as out of service. All equipment that is stored within the metrology cage or med cage is considered out of service and does not require individual identification. However, the med cage is a limited access area. Upon completion of calibration and providing the equipment is found satisfactory, it will be tagged with a calibration label. This label will indicate the calibration date and the due date of the next inspection. This label will be stamped or initialed by the person performing calibration. Next, a printer allows for custom labeling and easy inventory control. Pre-printed labels do away with the printer but require the maintenance of separate label stocks for each product. After the print process, the labels move on the applicator. The types of applicator is determined by labeling requirements. One or multiple labels, pressure, sensitive or glue on, vacuum applied or wipe on, box cylinder or odd shape. The application methods are as varied as the production needs they must meet. The backing substrate of pressure-sensitive labels is rewound on take-out spindle for easy disposal. Next, the advantage and disadvantage in metrology fixtures. There are two metrology fixtures, fixed position and rotational position. Whether you choose the fixed position or the rotational position fixtures, they can be designed and manufactured to accommodate single or multiple stations. The number of stations will largely depend on the number of parts that you wish to measure, along with the available size of your coordinate measuring machine or vision measuring machine table. Okay, we go to fixed position fixtures. The advantage: part-to-part positions can be closer. This yields a maximum number of parts for a given area. Next, overall fixture heights, the Z dimension, are lower to the machine table. This is a benefit as the measuring machine's Z-axis travel is a constraint. For the disadvantage, loading, unloading, and reloading of the same parts is time-consuming and lead to damage or distortion of the parts, which will ultimately lead to dimensional failures. It will also require fixture per orientation. For rotational, the advantage is less time and cost involved in qualifying this type of fixture. Its fixture setup times greatly reduced over having multiple fixed position fixtures. The routine run times are generally faster. Also, the load and unload the part only once. That means less human intervention. For the disadvantage, the weight ratio of the rotational type as compared to fixed type is greater. The y-axis row spacing is larger than that of the fixed type in order to accommodate the rotation of the rows. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. I am Ridzuan bin Hussein. So today I would like to introduce to you about metrology product. Metrology is the study of measurement. So metrology product is product to calculate the measurement. Today I have three different products. First, ruler, Second, vernier caliper, and third, I have slip gauge. This product always used in measurement process. Let me introduce to you with first object, ruler. A ruler is a measuring instrument consisting of a thin strip of wood, metal or plastic that has a straight edge and line measurement marking along the edge. Rulers are sometimes referred to as rule or line gauge. Rulers used for precision measurement may be certified by the National Institute of Standards and Technology, which is a measurement standards laboratory agency of US government. After that, we have steel ruler. A steel ruler is a straight flat piece of metal. Very similar to a ruler, they can be flexible or rigid and are usually 6 until 12 in length. Steel rulers are generally thinner than a desk ruler, which make them more accurate since the measurement markings are closer to the surface being measured. Steel rulers are used in engineering, math and geometry and technical drawing for their accuracy. Normal error when used ruler is parallel error. Parallel error is the error or displacement caused in the apparent position of the object due to the viewing angle that is other than the angle that is perpendicular to the object. So make sure your eyes position is 90 degrees from reading place. As you can see in the picture given, the perfect eye position is 90 degrees from reading place. This thing is really important to make sure you doesn't make any error when you read the measurement. After that, we have vernier caliper. Vernier caliper is an instrument that is used to measure internal and external dimension and distance. Vernier caliper can measure accuracy to 100 of a millimeter and 1000 of an inch. With a vernier caliper, you can make more precise measurement than you could with regular rulers. On a vernier caliper, there are two types of scale. The main scale remains fit to the device and can be found on the length of the caliper. It works like a ruler, where the other scale is portable and is divided into 10 sets of equal length. As you can see in the picture given, vernier caliper have a lot of components. First, we have inside measuring surface, inside measuring jaw, set screw, main scale, depth standard surface, depth bar, main scale graduation, vernier graduation, thumb grade, slider, outside measuring jaw, outside measuring surface. These components have different functions. All of these components is really important for the user. Normal error when we use vernier caliper is zero error. Zero error is defined as the condition where a measuring instrument registers a reading when there should not be any reading. In case of vernier caliper, it occurs when a zero on main scale does not coincide with a zero on vernier scale. The zero error may be of two types. When the scale is toward number greater than 0, it is positive. When the scale is toward number lower than 0, it is negative. The method to use a vernier scale or caliper with zero error is to use the formula. The formula is actual reading equal to main scale plus vernier scale minus zero error. Positive zero error refer to the case when the jaw of vernier caliper are just closed and the reading is a positive reading away from the actual reading of 0.00 mm. If the reading is 0.10 mm, the zero error is referred to as plus 0.10 mm. Negative zero error refer to the case when the jaw of the vernier caliper are just closed and the reading is a negative reading away from the actual reading of 0.00 mm. If the reading is 0.08 mm, the zero error is referred to as minus 0.08 mm. For the last product, we have slip gauge. Slip gauge were first developed by Johnson and sometimes also called as Johnson gauge blocks. These are rectangular blocks of steel having a cross-section of about 32 mm x 9 mm. Slip gauge are universally accepted standard of length in industries. Slip gauge are made in 5 grades of accuracy: calibration grade, grade 00, grade 0, grade 1, and grade 2 in the decreasing order of accuracy. For calibration grade, this is special grade and is used for experimental work, research work, and for measurement and inspection of other gauge. Grade 00, this is also termed as inspection gauge block. This is used for highest precision work such as measuring grade 1 and grade 2. Grade 0, this is used for tool room or machine shop inspection. Grade 1, this is used for more precise work such as setting up sign bar, checking gauge, measurement of component tool, and etc. Grade 2, this is used in workshop for raw check, for ordinary inspection work, for setting up machine tool, and for measurement where production tolerance and relatively wide.